All right, so now that we know what makes an experiment a binomial experiment, let's talk about how to calculate it. So the formal definition, the original definition that we could use to calculate the probability of X number of successes has us using these three sets of parentheses. So the first parenthesis is the combination. The second parenthesis looks at the number of successes, and the third parenthesis looks at the failures. Now, this is the formal formula for this, but I like to think of it like this. We're going to take the first set of parentheses is your n choose r, or n choose x, I should say. So n is the total number of outcomes, x is the number of successes. This is where we're going to use our calculator, the n choose r, to get that value. The second parenthesis is going to look at the probability of success. So we're going to take the probability that we'll get what we want and raise it to however many successes that we want. So the second parenthesis looks at our successes. The third parenthesis looks at our failures. So if it's an 80% chance of success, then it's a 20% chance of failure. Remember, these two probabilities should add to 1. And then how many failures there are is the difference between the total and how many successes there are. So if we just subtract n minus x, we'll get the number of failures. And we would type each of these into our calculator and multiply them all together and get our final answer. And that's what this old school formula looks like. But lucky for us, our calculator does the same calculation a lot faster. And so that's what we're going to focus our attention on today. Instead of setting it up like this, if you see this on like a worksheet key or something, that's where it comes from. But from now on, we're going to use Binomial PDF. And to get that function on your calculator, you're going to press the second button and then the vars button, and then you're going to scroll down until you see Binomial PDF. And it's going to ask you to plug in 3 values, because the calculator needs to know like what it's working with. So the first value is n, which is your total number of outcomes, however many people you're surveying, whatever that is. Then P is your probability of success. So what is the chance that you're going to get what you want? And then X is the number of successes that you're investigating. And what's really nice is the calculator takes all that information and very quickly does this exact same calculation from the old school formula. Okay, so let's look at this first example, and we're just going to get used to doing this on your calculator. By the way, you do need a graphing calculator in order to do this. So for right now, you can just use the Calculate 84 app on your iPad. So this problem says about 20% of workers in the United States commute to their jobs by using public transportation. It says that we're randomly selecting 8 workers. So that would be our total number of people that we're looking at. So I'm just going to highlight that in blue. So 8 workers. And it wants to know, use the binomial formula to find the probabilities below. There was actually one more thing that we read that's important, is this 20%. So that's 20% of workers commute to their jobs using public transportation. So as we look at what they're asking us, find the probability that exactly 3 of them commute to their jobs by using public transportation. So if we write out the information, and I like to do this in the margin here, there are a total of 8 people, 8 workers that we surveyed, and we said, hey, do you use public transportation? And according to this blurb, 20% or 0.2 use public transportation, PT. That means the number of people who don't, a failure, would be 0.8, who don't use public transportation. And then if we look at letter A, it wants us to know what the probability is that exactly 3 of them, that's our X, use public transportation. So according to what we wrote up here, we're going to let our calculator do the work. So you have to write out and show me what you're typing in. So Binomial PDF, and then the 3 values in the parentheses. So remember, we surveyed 8 workers. The probability that they use public transportation, the probability of success, is 0.2. And for this question, they're asking us, what's the probability that exactly 3 of them use public transportation. And so this is what we have to type into our calculator. So let's go ahead and do that. We're going to press second and then vars. Vars is in this math row, but all the way 4 buttons to the right. So we have second vars, and then you have to scroll down until you see Binomial PDF. Notice there's a PDF and a CDF. Right now we are choosing Binomial PDF. And then it prompts us. It tells us what we have to type in. So we're going to type in 8, and then we need the comma. The comma is above the number 7. Do you guys see the button above the number 7? Then 0.2 for the probability, comma, 3, press enter, and it gives us the probability that exactly 3 of the workers use public transportation to get to work. That exactly 3 of the 8 people that we surveyed said, yeah, I take the bus, or yeah, I take the train, or something like that. It's a pretty low probability, but it exists. Okay. So Binomial PDF is great because it does that calculation really easily. You just have to know what to type in. But the Binomial PDF works when we have an exact number of people that we're asking. But as you see, there's like A, B, C. There's lots of different ways, questions we can be asked. So let's keep reading and see how each question changes slightly. So letter B says, find the probability that 3 or 4 of them commute to their jobs using public transportation. So this or reminds me of or probability. So it reminds me that if I want the probability of 3 or the probability of 4 people saying yes, that I use public transportation, when we have or probability, doesn't that just mean we need to add the individual probabilities, going back to the very beginning of our chapter? And so that's what we're going to do. We're going to calculate the probability of 3 or 4. So individually, they each get their own Binomial PDF with the 3 values in the parentheses. Again, make sure you're always showing me what you're typing into the calculator. So we have 3 blanks here and then 3 blanks here. Now notice it's the same scenario as before with the probability of 0.2 that we're asking 8 people the question. But in this guy, the probability of 3, we're going to put a 3 here. And then this guy, probability that 4 said yes, we're going to change the last value because this one we want the probability that 4 of them would take public transportation. Okay, so go ahead, pause, type this in your calculator, and then come back to the video to see if you got the correct values. All right, so binomial of 3 is 0.1468. We got that from the previous one. This one you should have gotten 0.0459, and if you add them together, the total probability is 0.1927. Okay, so that's the or probability. We just had to do the Binomial PDF twice and add them together. So that's great. So we're going to see like exactly 3. I'm going to go back and box that term exactly 3. So we use Binomial PDF once. Or probability, we used Binomial PDF twice and just added the values together. And then this last one is the trickiest one. This one has the phrase at least, and this one is at least 1. So this is where we need to think about what's going on. So it's saying, we ask 8 people. So we ask the first person, second, third, fourth, all the way to the 8th person, right? 1, 2, 3, 4, 5, 6, 7, 8. It wants to know what's the probability that at least 1. At least 1 means that as you ask those 8 people, at least one of them said yes. So 1 or 2 or 3 or 4 or 5 or all of them. But what we're leaving out is the fact that it could have happened that none of them said yes, that they use public transportation. So we want the probability of all these guys of 1, at least 1 is 1 or greater. And we could do that. We could find the probability of 1 and put a 1 here. Probability of 2, put a 2 here. 3, 4. We'd have to do this Binomial PDF 8 times, which isn't impossible, but it would take a really long time, and add them all together because it was 1 or 2 or 3. But by looking at this, wouldn't it be easier just to eliminate this guy? what if we looked at this and said, let's see, I need a new color. What if we looked at this and said, the probability of all of these together should equal 1. The probability of all those together should equal 1. So if we eliminate or subtract away the probability that 0 of them said yes, then doesn't that leave this probability that they're asking us for? And so this is the idea we're going to use. I think this would be way faster to calculate versus adding together all 8 of those. So that's what I'm going to do. I'm going to do, for at least 1, I'm going to do 1 minus the probability that 0 said yes. So 1 minus, and I'm going to do binom PDF, and it's going to be the 3 values again. It's going to be the 8 people we asked, the probability, the 20% probability that they say yes, and the probability that none of them took public transportation. So they all drove, right? There is a chance that that could have happened. And so if we type that into our calculator, then we'll be left with this probability that at least one of them said yes, and we get 0.8322. So we can type that in our calculator. I'll do it one more time over here. So I'm going to do 1 minus this time. Second vars, scroll on down to binom PDF, and I'm going to type in 8, 0.2, 0, and we get that probability of 0.8322. So this at least phrase is the trickiest one, but once you think about it, it's actually not too bad. If you see the phrase at least, you're going to do 1 minus the probability of 1 fewer. So if it's at least 1, it's the 1 minus probability of 0. If it was at least 4, then it would be 1 minus the probability of 3, right? It's just 1 minus 1 fewer. All right, so those are the different scenarios we're going to see with binomial probability. Let's practice it again with a different scenario. So number 4 says the probability that a transplanted tree survives is 85%. So I don't know if you guys have seen, sometimes in communities they plant all these trees in a certain area and then they transplant them into different parts of town for landscaping. And so it says that the probability that the tree survives being transplanted is 85%. If a community transplants 10 trees in a park, use the binomial probability to show these things. So let's get our basics down. N, how many total trees are we talking about? 10. What is the probability of success that the tree survives? 0.85, which means if we needed the probability that it fails is 0.15. So the probability that it fails is 0.15. And then every question asks different things. So letter A says find the probability that exactly 7 trees survive. So this one is our most basic. We're just going to do binom PDF with the 3 blanks. In this case, we are looking at a total of 10 trees. The probability that the trees survive after being transplanted is 0.85. And then for this question, we want to know that exactly 7 of them survive. So binom PDF 10, 0.85, 7. And then we just type that into our calculator. Go ahead and take some time to do that. You should get 0.1298. So again, the exact probability is just binom PDF, pretty basic. Part B jumps straight into the phrase at least 7. So up here, remember when there was at least 1, we did 1, the total probability, minus the ones that we don't want, which would leave us with the ones that we do, right? So if we're talking, what's the probability that, we transplant 10 trees, what's the probability they survive? These are all of the total possible outcomes. None of the trees could survive. 1, 2, 3, all the way to all 10 of them could survive. These are all of the possible outcomes. And we know that total, the probability of all these individuals together should add to equal 1. Well, they want the probability that at least 7, so 7 or 8 or 9 or 10 survive. This is the probability we want. And we could calculate it by doing 1 minus this probability. or I'm sorry, we could calculate by finding the probability of 7 plus probability of 8 plus probability, and so on. Or the easier way is to do 1 minus the probability of the ones that we don't want. If we eliminate the probability of 6 or fewer, right? Or 0 to 6. And so the way we're going to do that, this way is easier, I think. We're going to do 1 minus the probability of 6 or fewer surviving, and then we'll be left with these guys. And so the way we're going to do that is 1 minus, and then to do this one, we're going to actually use a different binom function. And I'm sorry, I made the mistake up here. It shouldn't be binom PDF. This should be binom CDF. Can you guys go correct that for me? Binom CDF. We have a second function for this. So binom CDF. And we're going to use this in our calculator. The good news is we plug in the same value, so it's going to be a total of 10 trees. Probability of success is 0.85. And for this one, though, if we want 7 or greater, then we're going to subtract 6 or fewer. So we're going to put the number 6 here. And so we're going to take our calculator and do the same thing. Yeah, sorry about that. That was my bad there. We're going to do 1 minus second vars, and you're going to scroll down this time to binom CDF, and we're going to type in 10 trees, probability of 0.85 surviving, and we want to know the probability of 6 or fewer. So if you want 6 or fewer, use binom CDF, and that is, so 1 minus that probability is I'm sorry. So if we do the 1 minus that, we get the total answer of 0.95. That's the probability that 6 or that's at least 7 would survive. That's a pretty good likelihood. So this is the probability for this right there. So if we took away the probability that we don't want, so we took away this probability so that we were left with a probability that we did want it. Okay, so when you do the 6 or fewer, you're going to use the binom CDF. So let's add that to our notes up above here. So the binom PDF is when you have an exact number. The other option is we can use binom CDF, and it's the same 3 to begin with. So it's the N is the total. P is the probability of success, but this time, this one is X is less than a certain number. So what we're going to use for this one, this is when we're going to use the numbers of less than or fewer than a certain number X. And I'm going to put a star here. We use this for 1 minus binom CDF is for at least. So this is the strategy we use for when we see the probability of at least something. Okay. So we're just summarizing our strategies up here. Feel free to pause and rewind, do whatever you need to do to get that. Okay, so on the last one, find the probability that 3, so that's an exact number, so PDF, that 3 trees do not survive. So the wording of this one is different. What we want, a success in this case, is that they do not survive. So because it did ask for an exact number, we're going to use binom PDF, and we're going to have the 3 blanks. Again, we're talking about 10 trees, and we want exactly 3 of them to do what we're asking. But this time, what we want is for them to not survive. So if we go back and look up here, the probability that they do survive from the very beginning is 0.85. So the probability that they do not survive would be the complement of 0.15. So that's what we're going to put in here. And so we can just type that into our calculator, and we would get the answer of 0.1298. So there we have all the different scenarios. We have an exact, we have 2 examples for an exact probability. Make sure you know what we want, so which probability of success you should use, and then the exact number goes in the last one. And then we have our special case phrase of at least something, and we talked about the strategy to do that is 1 minus binom CDF of 6 or fewer to get that probability. Okay, let's try one more. This time we're not going to get the decimals. We're not going to type them in our calculator. We're just going to look at how to set them up. Okay, so this is talking about a survey found that 27% of adults say that Facebook is a major source of news for them. You randomly select 5 adults and ask them if Facebook is a major news source for them and use the binomial formula. So we can say that we are talking to a total of 5 adults, that the probability that they said yes, Facebook is a major news source is 0.27. Which means the complement that's not if they ask us about that. So if they ask no, which I see down here, so they said yes. So the probability that they said no, it's not, is the complement, 0.73. And then let's go question by question. So here I see exactly 2 said yes. So an exact number says we should use binom. And then the 3 blanks, we talked to 5 people. The probability they say yes is 0.27. We want to know that exactly 3 of them said yes. So that's what we would type into our calculator. Letter B, what's the probability that at most 2 of them responded yes? So let's look at all the different possible outcomes. We could ask 5 people and none of them could say yes, that Facebook is a major news source, or 1 or 2 or 3 or 4 or 5 of them could say yes. This phrase is new. We haven't seen this yet today, but let's think about it. At most 2. So that means the most people we want to say yes would be 2. So it would be 2 or fewer. So at most 2 is the same as 2 or fewer, or 2 or less, which reminds us that we're going to use binom CDF. The binom CDF does less than a number. So we're going to do, out of the 5 people, the probability they said yes is 0.27. And this time we want to know less than 2. So we're going to put a 2 in there to calculate, and that's what we would type in to get this probability, the probability of 2 or fewer. So PDF does exactly. CDF does fewer to the left, and then 1 minus binom CDF gets you the probability to the right. Okay, keep going. So letter C says fewer than 2. So very similar to the one we just did, but this is a slight change in the verbiage. Fewer than 2 does not include 2. So we're just going to include 0 or 1. So we could use binom CDF again and just change this to 1, or it's possible to just use or probability. So we could do the probability that 0 said yes or 1 said yes, in which case we would use binom PDF twice. So we'd do 5.27 and 0, and then or do the same thing, binom PDF. We talked to 5 people, probability they said yes is 0.27, and then or 1. And then you would just calculate those separately and then add them together. So notice the difference between the phrasing. It does change your calculations a little bit, where this one we included 2 and then went lower, and this one we didn't include 2 and went lower. All right, letter D is different because it's talking about those who responded no. So it's an exact number, so binom PDF. Binom PDF, because it's an exact number. We talked to 5 people. We want to know the probability that 3 of them said no. So if we go back up here, the probability that they say no is 0.73. So we're going to put that in the calculation. and then we see that at most 2 said no and fewer than 2 said no, it would be the exact same thing as these guys. It would just be this probability, and here would be changed to the 0.73. Okay? All right, I hope that helps. Go ahead and practice on your worksheet now, and make sure you are doing the work, typing it into your calculator so you know where to find everything. All right, we'll go through questions tomorrow. Have a great day.